Okay, so take a minute and put your date and your title, parallel and perpendicular lines. Hopefully we know a little bit about this already. We should know that parallel lines are two lines that never intersect. I shouldn't try to freehand draw that, of course, because it's too hard on here. So we'll just do it like this. Most of the time, parallel lines are marked with a couple of letters. So like if this is A and this is B, so that means that's line A, B. And then this was C and this was D. This would be line CD. Put a line over that. So when they're parallel, we would say line AB is parallel. It's a little parallel sign. If I put CC, sorry, it should be CD to line CD. So that's the little parallel symbol, okay? Then we're also going to do perpendicular lines, and hopefully you remember that perpendicular lines are two lines that cross at 90 degrees. This little box means 90 degrees or right angle. So the same thing, if we had this was A and this was B, and then this was line C and D, we would say line AB, and then this is the perpendicular sign. It looks like a little upside down T or a little perpendicular lines. So we'd say it's perpendicular to line CD. Okay, so you have the parallel, which is quite simple, and then the perpendicular is like an upside down T. It should just be two lines that meet at a 90-degree angle. Okay, so we're going to explore this relationship between these two things. We want to look at the parallel first. Obviously, parallel lines are two lines that continue forever but never intersect. Okay, so if I look at this line here and I want to create its linear equation, first we know that we're going to put it into slope-intercept form, right? So I know B is the y-intercept, so I'm looking at this line, 1, 2, 3. 3 is my y-intercept. My y and my x stay there, and now I have to figure out my slope. So I just look at 2 points, goes up 1 over 1, up 1 over 1, up 1 over 1. So it has a slope of 1, okay? So this is a parallel line underneath it, right? So let's get its equation. So we see that the y-intercept is at -2, right? We have our y and we have our x. We can just leave that -2 instead of -2. And I look and I see that it goes up 1 over 1, up 1 over 1, up 1 over 1. So that should make sense because parallel lines never intersect. They're going to rise and run at the same rate. If they have the same rate, they can never cross over anywhere. So one of the biggest things that we need to know when we're doing parallel and perpendicular lines is their slopes will always be the same and their y-intercepts should be different. If they're not different, then it would have to be the same line. So for my rule here, we need to know, oops, parallel lines must have the same slope, but a different y-intercept. Okay, all right. So we want to look at these types of lines. These are two parallel lines, right? But the slopes are very different on these lines. First, you have to ask yourself, is it a function? Well, if I were to draw vertical lines through these two lines, it would pass in two spots. So yes, it's a function, okay? So we know the y-intercept here is 1, 2, 3, 4, right? And we know the y-intercept here is at 1, right? And then we're looking at the equation of this line. And these are both positive, so I put pluses here. And then I want to figure out what the slope is. Well, it's not rising anything, but it's running a whole bunch. So the slope here for these types of horizontal lines should always be 0, right? So that would be 0x. Well, you know anything times 0 is 0. So very simply, when you have two horizontal lines, the equation should always just be y with the constant, and you should know that these have a slope of 0. So these have to be parallel, okay, when they're in this state. All right, so let's look at the opposite. The opposite is here we have two parallel lines, but if we were to do the vertical line test, it wouldn't pass it because it's going through every point. So here we have to know that our slope is undefined, okay? There is no slope. It's not a 0 slope. It has no slope because it's not a function, right? So this is not a function. Remember, FCN stands for function. So here, this is the x-axis. It doesn't even cross through the y, right? The x-axis, that's at 1, 2, 3, 4, 5, 6, 7. So that's at 7, and this one is at 4. So the equation of the line is x equals 4, x equals 7. So these are parallel lines, but you have to know that their slope is undefined because it doesn't pass our vertical line test. Okay? So now let's look at perpendicular lines. Here we can see, and sometimes it's hard to tell. When we do these on your calculator, you really have to rely your knowledge on slope and y-intercepts because our graphics on the calculator don't always show a 90-degree angle very well. So you have to rely on your math skills. But this is at a 90-degree angle. So therefore, these are perpendicular lines. Okay. So perpendicular lines, oops, intersect at 90 degrees. Oops, I spelled them. Okay, so let's look. Hello. Can't spell degrees. All right, so let's look at the equations of these lines and compare them. So here, this one, if we look at our green line here, green, the y-intercept is at 3. And then we can see it goes down 2 over 1, okay? So I can say my slope is down 2 over 1, and then my y-intercept is at 3. So that's the equation of this line. Or I can write y equals negative 2x plus 3 if I want to make it look a little nicer. So if I look at this one has the y-intercept of negative 2, and it goes up 1 over 2. So the equation of this line is 1/2 x, and then the y-intercept is negative 2. So if we look at these two equations, hopefully you notice something about the slope. Okay, the slope of this first one is negative 2 over 1. The slope of the second one is 1 over 2. So you should notice something significant about these numbers. They're the reciprocal. One is negative and one is positive. Okay, so we can tell that these two lines are perpendicular by looking at their slopes. If they're negative reciprocals, they are perpendicular lines. So the slopes must be negative reciprocals. Now remember, reciprocals is like the flip, and negative means it's the opposite sign. Okay? All right, and then let's look at one of these situations here. Here's pretty tough because you have to look at the slopes to see if it's perpendicular or not. Here, this slope, we just said, has a slope that's undefined, and then this slope is 0. So when you're dealing with horizontal and vertical lines, they're perpendicular if the slopes are opposite, undefined, and 0. Okay? So take a minute, write that down. So here's kind of the gist of it. When you have a slope of a over b, so any number a and any number b, they are parallel if they're the same. So if it's a over b, it's a over b. They're perpendicular if it's a negative reciprocal. which means it's negative b over a. Okay, so let's try a little practice. If I want to know the slope of m equals negative 2, what would its parallel slope be? Right? If I want to know the perpendicular slope of a line with negative 2, what would it be? And then let's do some practice with the 2/3. And the 0, which is the tricky one. Make sure you're writing this one down. Okay, and more on this tomorrow.